Okay, in this video I will discuss diode has half wave and full wave rectifier. Now this is the aim to verify diode as a half wave and full wave rectifier, and apparatus required are diodes, resistors, capacitors, step down transformer, choke, multimeter, etc. And formula is only one formula is the ripple factor equal to AC voltage divided by DC voltage, and circuit diagram for half wave rectifier is there, and this is for full wave rectifier. Okay, now see the table. Okay, this experiment is on without filter. Without filter we are doing, and tabular columns are serial numbers are there, and AC voltage is there, DC voltage is there, and ripple factor is calculated using the formula. And full wave rectifier, similarly we have serial number 1 2 3 4 and AC voltage, DC voltage, and ripple factor, and this is the calculation part. Ripple factor can be calculated by using the formula AC voltage divided by DC voltage, and result will be there, right? Okay, now I'll discuss first case. We'll discuss half wave rectifier. In half wave rectifier only one diode will be used. Okay, now see, these are the diode 1 is there, and this is diode 2 is there, and D3 D4 D5 is there. This is not using. Okay, this side we have resistances R1 R2 and R3 R4, 4 readings will take, and these capacitors are there, C1 C2 C3 C4 is there. This is also we are not using, only we are using resistances and diodes. And this is step down transformer, and choke will be there here. In step down transformer we have 3 connections. One is 9 volt is there, one more 9 volt is there, and this is 0 is there. Okay, we will make the connections of half wave rectifier first. Okay, now from this step down transformer of 9 volt, this 9 volt black, this 9 volt is connected to the diode 1, right? And output of the diode is connected to the resistance. Output of the diode is connected to the resistance. Now here 2 and this one. Now see, here 0 is there, and this 0 is connected to the one more side of the resistance. Okay, now see, this is one more side of the resistance. At this place we put the multimeter. Okay, or we can connect the multimeter. Okay, at this point we will take one wire, right? Otherwise no, neene ಏನು ಮಾಡಿದ್ದೇವೆ. Okay, take the wires, put this one. Okay, this is one side of the multimeter, and another side we need one more wire. No, this is for, we'll take one more wire, right? Alright, now see, multimeter is connected across the resistances. Now see, same thing here, multimeter is there. Okay, take one is this one multimeter, one side this plus red, hold this straight, and similarly another side one is connected to one more side. ಇಲ್ಲ ಉಲ್ಟಾ ಆಯ್ತು ಇದು ಈ ಕಡೆ, okay, right? This, otherwise we can connect directly this one. Where it is? Okay, right now. Okay, right, this one. Okay, it is connected to multimeter. ಯಾರಾದರೂ ಒಬ್ರು ಇಟ್ರಿ ಅಲ್ಲೇ ಆಯ್ತು. Okay, now see, connections are completed. These two are connected to the multimeter. Here multimeter readings will take this one. Okay, switch on the mains, and switch on the main button. Okay, now light is glowing here. Okay, we are discussing first one. Okay, in multimeter reading, okay, we both will calculate AC and DC. Now see, what is the reading here? 4 point something is there. Okay, now see, this is the first reading of DC volt. Okay, now see, it is 4.0 is there something. Okay, table. Okay, in table it is 5.0 is there. First reading is 4.0 is there. Similarly this is DC, and I am taking AC voltage. AC is also 4.9. Okay, this is the first reading, and one is 4.9, another one is 4.8 is there, 4.8, and ripple factor is calculated. Okay, now similarly we can calculate remaining 3 resistances. Now I am removing this one and taking second R2, R2, and same thing here also I am taking R2 reading. Okay, similarly we can calculate both AC and DC. Now see, here AC is 4.2 is, DC is 4.2, again AC is also 4.9 is there. Okay, I can put this value in tabular column, and similarly we can continue the another two readings. Okay, now see, this is R3 reading, this is R3 reading. Okay, similarly we can calculate both here AC and also AC and also DC, right? Okay, and last reading is same thing, this one R4 is also calculated. Here also we can calculate both AC and also this. Okay, now this completes the half wave rectifier. Okay, now we'll discuss full wave rectifier. For full wave rectifier we are using both the diodes, D1 and D2 both we are using. Now since this 9 volt is connected to D1, and same thing here, one more 9 volt is there, this 9 volt is connected to the D2. Okay, now see, I am shorting this one here, D1 and D2 is shorted here, right? Now see, this is the common here. Now I am taking one more wire, this wire is connected to, now see, at this two and similarly we have 1 0 here. Now see, this is connected to this one is connected to R1, and another one R is there here, R1 is there. This 0, from 0 we are connecting this side of the resistance. Now see, these two ends again it is connected to multimeters, right? Take the two wires, take two wires. Now see, again this side is connected to multimeter, and that end is also connected to the multimeter. Okay, multimeter connect ಮಾಡಿರಿದ್ದೇನೆ both the ends. Why this one? This is common now, right? Now see, both sides are connected to the multimeter here. Again same thing, we are taking the readings. Switch on this button. Okay, now see, similarly we have for R1 reading we have both here, DC is there, this is AC. For AC 4.2 is there, for 4 point it is changing. Similarly we can take DC, this is also 8.2. Okay, now see, same we can continue this to R2. I am changing this to R2. Okay, again we are getting both the readings, AC and DC, and AC is 7 point something, and we can write DC readings 8.6 is there. Okay, similarly we can take the another two readings by using this R3. Okay, again we are getting here DC volt and AC volt. Okay, this is DC and this one is AC. Okay, similarly we can calculate the final or last reading, this one, right? Okay, after calculation this type of reading we are getting here. Okay, now see, for full wave rectifier AC voltage is 4.4, DC voltage is 8.5, and ripple factor is 0.51. Okay, similarly we can calculate all these four resistances.